For our second example of solving systems of equations using elimination, we're going to begin with a set of two linear equations. The first one is 3x equals 15 minus 7y, and the second one is 5x plus 2y plus 4 equals 0. In this case, the x's, the y's, and the numbers are not all lined up into nice, neat columns. So our first step is to do that. I'm going to take the first equation, keep the 3x, move the 7y over using inverse operations, so I get plus 7y, and keep the 15 on the right-hand side. Now I need to make the second equation look just like the first, with the x's underneath the x's. So keep the 5x. The y's underneath the y's, keep the plus 2y. And I need to move the number over using inverse operations and get a negative 4 on the right-hand side. This system is now ready to apply the process of elimination, which means I need to look for additive inverses. I look at the coefficients, the 3 and the 5, the 7 and the 2, and I don't have any set of additive inverses or any easy way to make those additive inverses by just multiplying one equation. So I have to multiply both equations. And in this case, I'm going to eliminate the x's. My magic number I'm looking for is 15. So I want a positive 15 on the top, so I multiply it by 5, and a negative 15 on the bottom, so I multiply the whole bottom equation by negative 3. I could multiply by negative 5 on the top and positive 3 on the bottom. It doesn't really matter in this case. What does matter is that when I distribute those different pieces, it goes to every single one of my coefficients and my constants. So the top equation becomes 15x plus 35y equals 75. The bottom equation becomes negative 15x minus 6y equals positive 12. And this system here is preferable to every other system I've had because of the existence right here of the additive inverses. So when I add these two equations together, the x's eliminate, and I'm left with just 29y equals 87. One equation with one variable. That's very easy to solve and find out that y equals positive 3. So for my solution, I now have half of my ordered pair, y equals 3, and I need to go through and for my next step, find x. So I look at all of these different equations that I've had, and I could plug my y value into any single one of these that has both x's and y's. But in this case, I'm going to look for the easiest one, which is this one right here, because the coefficients are the simplest, and it's going to make the algebra the easiest. So I have 5 times the unknown value x plus 2 times what used to be y is now 3 because I've solved for it, and this all equals negative 4. So I do some simple algebra. I multiply 2 and 3 and get 6, and then I subtract the 6 from both sides. I get 5x equals negative 10, which in fact tells me that x equals negative 2. This fills out my solution set. Negative 2 comma 3 is the only ordered pair where these two lines happen to intersect.